Model Designer allows you to chain together multiple processing tools and build a workflow. And this workflow can then be run as a single command, and all the steps will be executed in sequence. The Model Designer has a lot of features which are a little different than your processing tools. So we'll learn how to use the processing tools and construct a model, and also what are the kind of model-specific tools that you need to learn about. Let's work with this data set. To start our exercise, we want to open up this project called Maritime Piracy. So from your data package, go and find the Maritime Piracy project, double click to load that into QGIS. This is one of my favorite data sets to work with because it's a really interesting data set. This is the data set of all the piracy incidents that happen in the sea. So whenever you hear some news report of some pirates attacking a ship, National Geospatial Agency in the US, they catalog that and they release a shapefile periodically cataloging all the pirate incidents that happened since 2000. So you have this historical database of all the pirate attacks that ever happened. And it's a fascinating data set. Let's open this data set and see what it looks like. The data set is named ASAM events, which is anti-shipping activity message. This is a fancy name of saying this is pirate attacks. So you can see there are over 6,000 records available in this shapefile. We have the date of occurrence, so when the attack happened, what kind of attack it was. There was some classification of the type of attack. Description, if you have some free time and you're bored, you can just look at and read this description. Again, fascinating of what goes on in the sea. Number of victims, etc. And you have this shapefile. This is a spatio-temporal data set. That means there is a spatial distribution that some attacks happen at different places. Also, it's a temporal data set. So we have attacks that happened over the last 20 years. And when we work with animations, we'll be using the same data to see how the attacks have changed over time. Right now, we're looking at the spatial pattern. And the first problem that we want to solve is, let's say you are in charge of security for some shipping firm. And so we want to deploy some resources to protect against piracy attacks. You are the GIS analyst and you are tasked with saying, where should we deploy our resources? Where do most attacks happen? So can we do some analysis to figure out which are the hotspots of maritime piracy? And we'll first solve this using the processing tools. And then, it takes a few steps to derive an answer. We'll now build workflow to automate all of that. So first, I'm going to just go through the workflow. You can watch and understand how the workflow is there. And then together, we'll build a model from that. You can see the way the project is structured, that our source dataset are in EPSG 4326. They are lat-long projection. We have set our project into this projection called Equal Earth Greenwich. So it's an equal area projection. This is a projection that is now used by NASA and many other agencies for global maps. If you're creating a global map and you want an equal area projection, which preserves the relative sizes of all the continents, this is the preferred projection to use. So when you're creating global maps or you want global analysis, do use this projection. This is the modern projection that is suitable for doing equal area analysis at the global scale. And we want equal area analysis because what we're going to do is we're going to create grids and we're going to count the number of incidents that happen in each grid. And if we created, let's say, a 1 degree by 1 degree grid, that grid will be 100 kilometers at the equator and maybe 50 kilometers at some higher latitude. So we can't compare two grids of equal sizes. We want the grids to have equal area. And that means we need to use an equal area projection. So we have simply set a projection of the project to be an equal area projection. We're going to use that to create a grid and then count the number of incidents that happen in each grid. And then we'll find the grid having the highest piracy incident. So the first step we want to do is we want to create a grid. QGIS has this algorithm called create grid. So we're going to use the create grid. We can create a hexagonal grid. Hexagons are useful because they are the closest approximation to a circle, which is continuous. So if you can't use circle, the next best option is hexagon. So widely used in geospatial analysis. It's asking what's the extent of the grid. And we need to get the extent from some layer. So we can say, look at this land layer, the landmass of the Earth. We want a global grid, and we can create a grid. But you can see there's a mismatch here. We want a grid to be created in an equal area projection, which is this EPSG 8857, but the extent is in EPSG 4326. And there's a mismatch. And when I run the tool, we will get an error saying that my extent and the grid projection doesn't match. So we need the extent in the same projection that we want to create the grid. So before we can even create the grid, we want to reproject our data to the target projection so that we can compute the extent in that projection. So the first step in analysis would be run a reprojection, and we say take a base layer, which is the landmass layer, and target CRS would be the project CRS. So whatever project CRS has been set, we just use that. So that's our first step. So I'm going to run this, and now we have a reprojected layer. And now we can use our grid algorithm and say, create a hexagonal grid, and my grid extent should be from the reprojected layer. And you can see my grid extent now is in the same projection as my target projection. And now I can use that. Since now we are working a projected CRS, we can specify a grid size in meters. So we can say my grid size about 200 kilometers per grid. It's a good starting point. So let's say 200,000 meters is our grid size. When we build a model, we'll make this configurable. So we can test different grid sizes. What happens if you do a 100-kilometer grid or a 500-kilometer grid? Right now, we're just doing the analysis just to test the workflow. So we're just using a 200-kilometer grid. So let's just run this. And you can see we got a hexagonal grid created. Now we want to count the number of points that fall in each of those grid. So if I just change the layer order, you can see most of the grids in the world do not have any piracy incident because they are on the land or they're in part of the ocean where it doesn't have piracy. So let's just extract all the grids which do not have any piracy incident. Let's just make our map much more cleaner. So I'm going to use this tool, extract by location, and say, take our grid and extract all the grids which intersect with at least one piracy incident. So we just extract those grids and we just remove all the grids which do not have even a single piracy point. So now we have grids which have one or more piracy incidents. And now we want to do our analysis to say where is how many incidents in each of the grid. So we have a tool called count points in polygon. We'll say take the extracted grid, count the points from here, rename the field as num points, and generate our output layer. And we get our output layer. If I open the attribute table, you can see I have the number of points for each grid. So this particular grid had 240 piracy incidents from our database and so on. And now we can say if I want to focus our resources, I can sort it and pick the grid which is having the highest piracy incident. And we can focus our efforts there. Any guesses of where this grid is? Any idea which part of the world would be that grid if I zoom to this? When I first did this analysis, I also expected this to be in Somalia, near the Horn of Africa. Let's see where this is. So I'm going to select this grid, and this is in Bay of Bengal. Though the piracy incidents that happen near this Horn of Africa, Somalia gets a lot of news attention. If you look at the overall history of piracy, there were a lot of piracy incidents that happened here, and then due to increased enforcements and a lot of steps were taken, and nowadays there's very little piracy here. Most of the piracy is in Southeast Asia. So when we explore this data over time, you'll see that there were certain years where the hotspots were all here near Somalia, and now they've moved into the Southeast Asia. So again, really interesting spatio-temporal patterns. If you take the data set as a whole, most of the piracy incidents are around this region. All right, so we did this analysis useful for our purpose. And many times when you do a GIS analysis, you show it to the stakeholder and they would say, what happens if we change our grid size? Can you do this with a 100-kilometer grid? And they will say, okay, let me go back, run my 10 steps, and I'll come back and show the grid. And then say, can you do this if you give more weightage to certain incidents? And it's okay, I'm going to redo my analysis and so on. So rather than redoing all the analysis, you can say, I know the workflow. Can I build a model? And I'll have some parameters that are configurable. I can just set the grid size, set the weights, and run it. And all my analysis will work as a single step. I don't have to do this. And this also helps you where you are working with stakeholders, you have your model, and as you are discussing, as you are kind of iteratively developing a model, you can test different configurations and then arrive at the most suitable one. So you can see we started with some data, we did 4 steps and we got our results. Can we now put them in a workflow so that I just want to click a button and I generate my grid without manually running all the workflows? Manually running this also is error prone, time consuming. I don't want to do this. So let's learn how to take this workflow and create a model. From the course material, we are now working on section 3.1 and we'll go through each step. And I want all of you to follow along. We'll do one step at a time. doing the model, there are many things that can go wrong. So do one step at a time, and in between, we'll do some checks and see if our model is working right. If something goes wrong, we'll go and fix it. So let's start working on creating a model. I'm going to remove all my layers first. We'll start with the Maritime Piracy project. So again, if you haven't loaded it yet, just load the Maritime Piracy project. We'll start from this point onwards. To create a model, we have to go to Processing and Model Designer. So go ahead and open up the Model Designer from the Processing menu. This opens a new window, and this window looks like a mirror image of your main QGIS window, right? You have the processing tools on the left, and you have a blank canvas in the middle. This is where we'll build a graphical model. It's a visual creation tool, so we'll drag and drop some tools, connect them, and say, do this first, do this next, and we'll build a workflow. Once the Model Designer opens, we need to enter a name of the model. So we'll just name it Piracy_hexbin. This technique that we are doing is called binning, where we create grids and count the number of things inside a grid. So that the geospatial analysis technique is called binning. And since we are using hexagon grid, the technique is referred as hexbin. So we're creating a hexbin model for doing our piracy analysis. We can just enter the name, keep in the processing toolbox, and all the models will be in this models folder. So whatever name you give will be available here. Further, you are able to give one more folder. If you give a group, there'll be one more subfolder inside. So if you like to do a lot of models and if you want to keep them organized by projects or by type, you can enter a group. For now, we don't want to enter a group. You can just say Piracy Hexbin. And then we click the Save button. So there's a Save model. When doing the model, if you do something wrong, you might get a QGIS crash or something. You did something in a model, just suddenly get screwed up. So it's a good practice to save your models at intermediate steps. So let's just save the model first. So I'm going to click Save. When you click Save, it's going to open this special folder. Do not change the folder. Keep your models at this folder. This folder is inside your QGIS profile. And by having the model here, when QGIS starts, it's going to look at all the models and load them in the toolbox. So if you save the model here, it'll always be there in your toolbox. If you load it somewhere else, it won't be there. You have to manually go and fetch the model every time. So make sure, do not change the directory, just keep in the models directory. You can name the model Piracy_hexbin and save it. It creates a file called model3. So it's a special text file in a format that QGIS understands of how the models are done. So now we have a model, which we have saved it, and we'll now start doing the steps. Here, you have two tabs here. One is the Algorithms tab. This is the same as your processing toolbox. All the tools in the toolbox are appear here. So you can select which tool you want to run in what sequence. You also have inputs. The way the models work is that the inputs are not static. It's not always this layer. You can say, I'll load some layer and I'll run my model as this input. So you can specify all the inputs that your model will take, and the user can configure that. And you can see all the different types of input. You can have a vector layer as an input. You can have a number as an input, and so on. So all the different kind of inputs that are possible in the toolbox are available here. So let's just make a model. We're going to make a model which will take a point layer of the piracy locations, base layer location representing the extent of the world as the base layer. And then we'll take another input of the grid size. We'll take this 3 input and do our analysis with the generated grid. So switch the inputs tab, scroll down and select the vector layer and drag and drop it into the canvas. As you drop it, you'll get a dialog saying that what's the name of the input? We're going to just name it as input points, input space points. And the geometry type of this would be point. So we say the user has to select a point layer, which we'll use as the piracy incidents. You have an option here, mandatory, that is it optional or mandatory, and we'll keep it mandatory. Once you have your input, you'll see this yellow box. Yellow boxes in the model designer represent inputs. So you can see my model right now has 1 input. Let's bring in our second input, the same type vector layer. I'm going to bring it in. This one, we'll name it as a base layer. This is the layer representing the land masses, which will derive our extents out of. And this would be a polygon layer. So let's say it's a polygon, and this also is mandatory. So you can see I have 2 inputs to my model. Let's bring in the third input of the grid size, where when we run the tool, we can select a grid size and our model will use that grid size to do our analysis. And this will allow us to run the model with different grid sizes. This will be of type number. So bring in the number input. On the input section, you have a number. You can bring in the number. We'll name this input as grid size, and we can make it an integer type. Some inputs have a default value and a range for validation. Let's just give the default value as 200,000. So every time we run the model, we don't have to give a value. It'll just take 200,000, which is 200 kilometers, as the input. So grid size is the number input. Name it grid size, type integer, and enter a default value of 200,000. And you can go and save the model. Now we have our inputs. Let's start building the workflow. And the first step in our workflow is to reproject the base layer. So similar way that we do in the processing toolbox, we do the reprojection. So find the reproject layer algorithm and bring it into your model. We're going to use the tool from the vector general. Remember, there are different tools which are similar to this. Make sure you pick the correct one. And we get a very similar dialog, but there are some differences here. It says input layer. Which one do we want to reproject? So it says using model input of base layer. So that's correct. So there are two inputs. It says whatever base layer has been selected, use that for the projection. What's the target CRS? We can select a fixed CRS, or we can say whatever is the project CRS. So we'll just set this and say whatever the user has chosen as the project CRS, let's just use that. This also makes it easy where you can just simply change your project CRS and run the tool. It'll just generate the grid in a different projection. And finally, there is an output. So the tool will generate some output. It says enter name if this is final result. If you do not enter the name, it'll be considered as an intermediate layer and it won't be saved. And you won't even see it. Yeah. So let's just click OK. If you've done this correctly, you should see a line connecting the base layer to the reproject layer. That means this tool is using base layer as one of the inputs. The other two inputs are not being used yet. I'm going to show the reproject layer again. This should be the configuration. Let's save the result. And I want to show you what the tool looks like. So there's a play button. If I just click this run model, I'll see a dialog like this, that I have this drop-down menu. I can select a polygon layer. I can enter some grid size and I can enter this. So this is what we built. So when you build a model, you get a new processing tool that you built with the inputs you chose. Right. So far, we've not defined any outputs yet. So there is no output. This is just your inputs. All right, let's do the next step. The next step in our workflow is to create this hexagonal grid with the extent that we have for the go and search for the create grid tool and bring it in here. Grid type, we can select the hexagon. What's a grid extent? Well, we have some options here. If I click on this 1, 2, 3 icon next to it, it says, is it a static value? Is it a pre-calculated value which you can derive by an expression? Is it one of the model inputs, or is it an output from an algorithm? Now, remember, we have to compute the extent from the previous layer, which has been reprojected. That was generated as a model output. So we have to select the input here as algorithm output. It says my extent is the extent of the reprojected layer. Okay, so far we have used the model input. If you use input, you have those two inputs. We don't want to use extent of the base layer because that will be in a different projection. We want to use the extent of the reprojected layer. So make sure you change this to using algorithm output and choose the reprojected one. Horizontal and vertical spacing, that's a grid size. What should we enter here? Should I enter 200,000 here? No, because if I enter 200,000, every time I run, it'll be 200,000. I want to use the value that the user selected when running the model. So drop down and say model input. And it says use the grid size. Similarly, model input, choose the grid size. So you can see that the tools are the same, but they are used dynamically configured values, that all the inputs come either from the previous step or the input that was specified by the user. So go and configure this, we'll click OK and show you what this looks like. If you've done everything correctly, you should see one connection from the reproject layer where it's using the extent of this to create a grid, and one connection to the input grid size. The connections are really good visual reminder if you've configured your model correctly. So pay attention to those. It's very easy to make a mistake. If you do not see those connections, or if you see connections where they should not be, go and reconfigure the tool and make sure you save your model, right? Hope you're getting the hang of this. Let's do the next step. The next step is to extract the grids that intersect at least one input point. So we can run the extract by location algorithm. Search for extract by location, bring it in, and say extract features from where. So we have to change this to the algorithm output, and we say we have this grid layer. You want to extract the stuff from grid layer. The default predicate is intersect, so we can leave that. And by comparing features from the input points, I'm going to click OK. And you should see now some more connections. If you're developing a more complex model, I request you to keep your models organized. So make sure you can adjust this a little bit so you can align those boxes so you know exactly what's going on. This will make it easy to spot any errors. Models can sometimes grow to be very complicated, and spotting an error can be very difficult. So I like to keep everything organized and say, okay, I'm building this workflow. This is the first step. It goes here. Second step, it goes here. And then I'm using the inputs as and when it's required. We have our extracted hexagonal grids at the location of the incidents. And now the final step is to count the number of points in each of those grids. Let's search for count point in polygon algorithm. Under vector analysis, you'll see the count points in polygon. Let's just bring it in. And it says, where are the polygons? This one has to be algorithm output, not the grid, but the extracted grid. So we don't want to count polygons in all the grids, only the stuff which we have extracted where there are at least one Paris incident. So make sure the polygons has to be using algorithm output, extracted, and the points have to be input. So yeah, let's count the input points. Everything else is the default. And this is our final result. So we want to see this result. We want to load it in QGIS and see the result. So we want to enter a name here. You can enter any name here. This will be the layer name that will be created. I'm going to enter it as aggregated. So you can use the name aggregated. Since we are aggregating the points to grids, you can name the layer as aggregated. So go and configure this tool where the polygons will come from the extracted grids. The input will be the input points, and the output would be the aggregated. Once you click OK, you will see your completed model with an output. Make sure you save it, and you can see my workflow looks like this. We're going to add some more stuff to it, but this is a basic workflow where we represent the layer for compute the extent, create a grid for that extent, extract all the grids that intersect the bias incidents, and then count points in polygon. But let's test and see if the model is able to run and generate the output. So click this green button, run model. It'll bring up a dialog like this. So this is the model that we built. We can select the base layer. You can see it will allow you to only select the polygon layer since we've configured it to accept only the polygon layer. Grid size, let it be 200,000 input points. And then let's just create a temporary layer and we can run this. So let's run this. You can see it's going to run 1, 2, 3, 4 steps, one after the other. And if everything worked correctly, you should see a new layer called aggregated in QGIS. And if you open the attribute table, you should see the same output that we had earlier generated. And this was the output that you could now generate automatically without running the steps manually. So test your model. If you're successful, try running it for different grid sizes. Try running it for 300,000, 500,000, and see how the results change. Let me just run it at 500 kilometer grid size. And now you can just see that I have this analysis done at 2 different grid sizes. And if I see the 500 kilometer grid and say, where is the highest grid? And my highest grid now is in Southeast Asia. So your grid size and grid alignment will influence your output. This is a very common problem that is known in spatial analysis called MAUL, Modifiable Aerial Unit Problem. That is MAUP. So MAUP is a problem which says that when you're aggregating stuff, your choice of grid size and choice of the units in which you're aggregating will really affect your outcome. And there's no solution to this. People use this for nefarious purposes. People say, I want to manipulate some statistics. You choose a different grid size and you can manipulate your output. As an analyst, it's your responsibility to test your output at different grid configurations. So this is also called a sensitivity analysis. When you do some analysis, you say, how sensitive is my output to the input parameters? If you change your grid size and suddenly all your highest grids are somewhere in the different part of the world, that means your output or analysis is very sensitive to the grid size. So you would do this for multiple grids and say, this is the area where all my analysis said these are the regions with the highest incidence of piracy. And having a model like this allows you to do sensitivity analysis very, very easily. Right? You can just run it as a batch process and you don't have to do any manual work. One of the advantages of building a model is that models are also part of a processing toolbox. So I can now run this as a batch process. So if I find my model in the models tab, I can right click and say execute as a batch process. So let me say I want to do 5 different outputs. I will take my input layer and I'll generate a grid size. I want to do it for 200,000, 250,000, 300,000, 400,000, and 500,000. I want to do all of this automatically. So I can run this as a batch process and say my output would be here. So we generate different outputs. You can say I have grids of different sizes, and I can now run this, and I can sit back and relax. QGIS will do all the hard work, running all the steps to generate grids of different sizes, and it'll generate outputs for all the chosen grid sizes. And this allows me to do sensitivity analysis, to test my sensitivity of the output to the grid size and so on. So you can see I've done all the work, and back in QGIS, I have all my grids loaded that were generated using batch process. And if we had to do this manually, again, it will take you probably 30 minutes to do error-prone, lot of manual work. Now you could automate this using the processing tools. Okay, so we're done with the model. When we save the model is saved on the computer where we are working on. And what if you are collaborating with other users? Say we have a project file and I'm sharing project file with each other, and you need to also send the model to them and saying, hey, here's my model that goes along with the project. Also, if you have multiple computers, you built a model in your office computer, you come home, you don't have a model there. So another useful practice to manage your data is that when you create a model, typically a model is always linked with a project. You are using the model in the context of a project. So I have this project file, I have this maritime piracy project, and I can say, it'd be nice to have this model available to all the users of my project. Whenever I send you a project file, you open this, the model is right there. So you can say, I have my inputs, here's the model, run it on the inputs. So in the model designer, you have one more button, and the designer at the top row, next to the save button, you have this green button. It says save model in project. Find that button and click on it. Once you click this button, save model in the project, it'll say model was saved inside current project. Now what happened here? Let's go back to our project. We have the QGIS project. Look at the processing toolbox. There's something here. There's an extra stuff here called project models. You get a new folder. When you load a project which has a model saved inside, you get this folder. And if you expand it, you can see I have my piracy hex bin right here. That means now when I save the project and I send you the project file, you have the model along with the project. So the model is saved inside the QGZ file. So it makes it much easier to manage, and I can just save a project file, generate data, and your model is saved inside. Whenever you open the project, the models are right there, and you can edit and see this. So this is another best practice, that always save your models inside the project. So when you share them, they'll be available to the users. If you want to catch up to this point, we have the project in the solutions folder called Modeler Checkpoint 1. If you load this project, you'll have a folder called Project Models, which has the model that we have built so far. So if you did not complete your model, or if you had an error, if you want to do the challenge, please load the Modeler Checkpoint 1 project from the solutions folder, and you have your model. You can right click on this and edit the model, and you have the model that we have built so far. And now you can do an exercise to improve the model.